Hey, this is the second part of our video on BGP Flowspec with NCS 5500. Today we will see the interaction with outbound networks and how we can automatically tackle a Memcached, an NTP and a TCP SYN flood attack. In the former video, we presented the Flowspec protocol and how we can configure it on iOS XR. For more config examples, I invite you to take a look at the support forum post Yosef published. The link is available in the description. Now, let's talk about one of the attacks we will handle today, the Memcached amplification attack. It has been popularized in early 2018, and this arbor page is a very good starting point. You can see, for example, that it is based on UDP 11211, but you will find many more details in this article. On this Cloudflare website, they provide details on the different steps used to build a Memcached amplification. Also, on this other site, they compare the amplification factor for most of the common DDoS attacks. You can see Memcached is by far the biggest. The last resource I recommend is the Shadow server website. They are scanning the internet on a daily basis to identify how many systems are vulnerable to amplification attacks. You can see 35,000 devices that can be used to create a Memcached attacks today. We note a drop in March 18, but since that time, the number is decreasing very slowly. That means Memcached attacks are here to stay. The good news for network operators is that BGP Flowspec is a perfect tool to tackle amplification attacks at the border of the network. We will demonstrate it today with our partner Arbor Network. Their SP system is able to detect these attacks and trigger auto-mitigation with Flowspec. Now, let's check our testbed. We are using an NCS 55A1 36H SCS. It's a system based on a Jericho plus ASIC with external eTCAM. You can see we have our BGP and BGP Flowspec sessions up, but no route or rule are received at the moment. The route to reach the victim is a static /24. During this demo, we'll use three different attack vectors. First, a Memcached amplification. Second, an NTP amplification, and last, a TCP SYN flood. The first two can be handled on the router with Flowspec. The last one will require a more advanced system to challenge the TCP traffic and differentiate the malicious packets from the legitimate sessions. We start checking the Arbor GUI and we verify we don't have any current ongoing alert. It's all clean. We now launch the Memcached attack from the traffic generator. On the NCS 5500, we check IPFix, and we quickly see that indeed we have entries for UDP 11211 with fairly large packet size. Back to the SP GUI. An alert has been created for this attack. And the Flowspec auto-mitigation has been triggered. With show BGP IPv4 Flowspec, we verify that a rule has been received on the router for protocol 17, that's UDP, and source port 11211. And with show Flowspec HAFI all details, we see we are indeed matching and dropping packets. We click on alert 3034 and we verify the attack packets are still seen even if they are dropped by the Flowspec mitigation. It's important to keep this visibility. It permits to know if the attack is ongoing or stopped. Now we can start the second attack vector. This time we simulate an NTP amplification. That translates in abnormally large NTP packets targeted to the victim. IPFix is sampling the streams, and now we have UDP 123 in the cache, still with Memcached entries. Automatically, the mitigation for NTP amplification is generated, and we can see it in the Flowspec section in the GUI. It uses the destination address, the source port UDP 123, and specific packet size ranges. On the router again, we verify the impact of this new rule. It's programmed and effective, packets are matched and dropped. With show policy map transient type PBR, we can see how the rules are translated locally in the router. On the graphical interface, the two attacks are clearly displayed. We can start the third vector now, the TCP SYN flood. It's not something BGP Flowspec can mitigate directly on the router, because you need an active device to help discriminating the good from the bad SYN packets. That's why the system will behave differently, injecting a /32 BGP route that will divert the traffic to the scrubbing element in Arbor solution, the TMS. Like we did for the first two attacks, we check IP fixed cache, and now we can find TCP/AT entries. We verify the route to the destination. It's now a BGP/32 that took precedence over the static /24. We check the details of our alert ID 3034. The TCP SYN authentication countermeasure is now dropping packets. That confirms the attack has been diverted to the TMS and is mitigated automatically. One last look at the attack against 11.200.0.2. These three attacks vectors are clearly displayed. Let's summarize the test we just performed. A Memcached attack has been launched against our victim. The Arbor SP detected it and automatically programmed a BGP Flowspec rule in the NCS 5500. Then we generated an NTP amplification attack, which has been detected and mitigated following the same approach. Finally, we started a TCP flood attack. It has been detected like the two others, but this time the system automatically injected a more specific BGP route to divert the traffic to the scrubbing device, the TMS. And none of this mitigation involved any human participation. To conclude, we demonstrated it's not required to perform any kind of deep packet inspection to mitigate amplification attacks like Memcached or NTP. BGP Flowspec on NCS 5500 is the right tool for this job, and it works very well with Arbor products, offering the perfect solution against DDoS attacks. We hope it was informative. Don't hesitate to post comments or questions in the section below. Thanks again for watching, and see you soon in the next video.